Okay, so an alternative to using the indane dione zinc chloride with the sandwich method for developing prints on thermal paper on the emulsion side is to use hydrochloric acid vapors. And so, as you saw before, you potentially have fingerprints with the sandwich method with the indane dione, where you can get fingerprints appearing on both the emulsion side and the plain back non-chemistry side of the paper. And what we're going to do now is use the HCl acid vapors to develop prints on the emulsion side. Now, the limitation with this is it will not develop any prints on the reverse side. So I'm just going to put some prints on our sample paper here. And they'll just glove up. Now with the hydrochloric acid, we have this container here. I'm going to decant some into a small scintillation vial using a pipette. Now, much like with the other chemistries, with the indane dione zinc chloride, it's prudent to make sure that the acid does not come in contact with the emulsion side of the paper, or it will discolor and obliterate any prints that are on there. So we don't need a large quantity of this. It's simply just to allow vapors to accumulate inside of an enclosed space. And so, in this case here, we'll set that aside. For our purposes here, I'm going to use this plastic container. I'll place the HCl in the center of the container, and then the receipts I will just kind of lay around the outside so that they're not in contact with the acid. And we'll close up the container, just put the lid on it and let it sit for a few minutes to allow any potential prints to develop. Now, ideally, it's nice to do this in a clear container where you can have the emulsion side of the paper facing outwards, and you can monitor it. If it's a clear housing, you can monitor to see the development, because it depends on the type of impression. It depends on the time since deposition. So, and depending on the how much of the paper itself, the composition of the paper, as well as the volume of the area, the canister that the acid vapors are allowed to permeate in. So we'll let that sit for a few minutes and then we'll check on it. The fingerprints, again, depending on the manufacturing process of the thermal paper and the proprietary construction of that paper, the prints may show up either a pale pink color, or a pale green color, or potentially black or gray in color. And there is no definitive test to ensure or to establish what color that's going to develop the prints on until you actually process it. When it comes to actually testing whether it's thermal paper or not, obviously you can dip it into the acid, and I'll just show you what happens, the reaction that it will have, and how rapidly that reaction takes place when I just deposit the acid right onto the paper. One thing to establish whether the receipt is a thermal paper or not is to just take your nail and kind of drag it along the edge of the paper, and you should see a discoloration where you've dragged your nail across the surface, and that will give you an indication whether or not that receipt is thermal. But generally speaking, you can tell by the smoothness and the sheen that's on the emulsion side Primarily on point of sale receipts is where you will find that type of paper being used today. Much the same as the old facsimile paper that was used. Maybe your grandparents have told you about that at some point. Okay, so we've let the HCl work its magic here with the prints on the thermal paper. So let's have another look and see if we've got any further development. Oh yeah. Okay, so these the prints that are visible on this will potentially fade over a period of time. They can also, as it's sitting out of the vapor chamber, you can actually sometimes see more development come. It gets more of a contrast initially, and then it might fade after the fact. So if you look, I'll just fold this down here so you can see where I'm referring to. But in the other areas here towards the bottom part of the first flexion crease and down below, you can see there's a significant amount of detail, and it's getting even clearer as it's now had time to air out after being in the vapor.